Thank you so much, Mrs. Yadav, for arranging this webinar, taking time and inviting all the students for it, and giving us an opportunity to deliver a lecture on Industry 4.2, that is Smart Factory with Digital Twin. So I'm very glad to be associated with such prestigious institution. Hope I will make this session more informative and interesting for everybody to attend. So, so let's start the session today on Smart Factory with Digital Twin. Before we could start the actual session, I would like to brief a bit about MTAB Technology Center. So, as Madam explained, yes, MTAB Engineers, the parent company, is a 35-year-old company where we started manufacturing CNC machines, robotics, mechatronics, automation kits, FMS, SIM. We used to deliver that to many institutions, and for past 15 years, we are also working closely with many industries, providing a lot of industrial solutions as well. So we used to conduct a lot of training to our customers using our training center. And in 2011, this training center has started as a separate company as MTAP Technology Center. And we focus primarily on skill development, skilling activity, and industrial consultation. This is our infrastructure in Chennai, where we have CNC machines, robotics, mechatronics, PLC kits, and all, and we conduct a lot of training to many of our customers. There are people from various countries also who come here to attend some of the courses. This is state of art infrastructure available in Chennai. These are the main business focus areas of MTC. So we call it as two segment. One is digital learning, another one is digital factory. The top two are digital learning, bottom two is the digital factory. So digital factory is where we provide a lot of industry 4.0 solution to industries, like in digital twin concepts or IoT app and IoT solution. And we also set up a lot of center of excellence. And whatever experience and whatever knowledge we gain on it, we convert that as digital learning part. So we have digital content, interactive content developed and made as a product, which is a skill on 365. And we give it to our customer for conducting training, taking additional skill programs and things like that. Those are the top two products that we actually do. Yeah, we are ASDC and IAC skilled sector partner. And similar to that, we have something called IHK in Germany, and we are also partnered with that. And our training center can provide IHK certification on CNC. We also partner with Siemens for conducting a lot of Siemens training, and I know we are also Siemens partner in providing some of the industry 4.0 solution. With that, I'd like to start the session today. Smart factory automation, smart industry. Today, I'm sure you would have heard this particular topic in many places. Many people would have been talking about it because today this is the hot topic where many industries and the requirement for such knowledge is very much required in most of the industries today. You take whether it is in manufacturing, process, automobile, no aerospace. Many areas is right now looking at smart industries and smart or industry 4.0 solution. What is this exactly? As I was explaining that many people are talking about it, there could be a lot of confusions. Which is the correct one? Whether the one I'm giving is correct or the other persons are giving it correct and things like that. Let me make it clear that smart factory or industry 4.0 is combination of different technologies which is coming into one place and making a product or a process smarter. So when I say we're bringing in different technology, it could be CNC or robotics, or PLC, image processing, whatnot. So the combination of various things to make it, it depends on what is the product and what is the process. We always believe in understanding the technology via an application because every industry applies the technology in a different way. That's where the variations or different kind of discussion is happening in industry 4.0. So a process industry might consume it in a different way, an automobile industry might consume it in a different way, right? So it depends on the product and process. The industry 4.0 technology or the content of the industry 4.0 technology changes completely. So we will be uh, going through a lot of case studies, applications in my webinar today. As I mentioned, because we believe in learning the technology via the application way. That way, we will get knowledge on how we can apply this in various different other industries or in different uh, product or different process. This is again a common slide that you would have seen it in many places. The evaluation of Industry 4.0. So 1.0, where the first level of manufacturing started, a basic mechanical way manufacturing was started, and then 2.0, where production lines were introduced and manufacturing was made as a actual line of work, and where we were not sure actually a revolution was happening or not. And then the 3.0 is where the revolution was started recognizing, and where robotics and PLC were actually introduced and automation was introduced in 3.0. And right now we are in 4.0, and we're going to see what is this 4.0. Now, as I was explaining that industry consumes it in a different way. It all depends on how industry takes. Since everybody are speaking about it, industry will not just take it as it is. They will apply, or they might take according to the concern that they are facing, or if they might be looking for any particular solution, and looking for some um, product for it. When we work out, see, as I mentioned, we do a lot of industry consultation work, and we, using our experience, we have categorized the customers into four, our customers concern into four major factors. These are the four major factors: speed, flexibility, quality, efficiency. Please to remember this slide. I might term this slide as slide number 3, and we might refer back here often. When we say speed, speed is like speed to market. We'll take an example like in an automobile industry, like the Hyundai Verna or a Hyundai Creta car. So right now, Hyundai Creta is, let's assume that it's one of the best car in the world and it is in the market. And I work for Ford. And if I want to release some competitive to it, like say Ford EcoSport, I have to release it within 1 month or 1.5 month in order to have take my share of market. If not, the market is totally consumed out. Say if I'm going to release a car in 2 years, Hyundai Creta might come up with different versions with much more advanced features, and my market is totally gone there, right? So speed to market, we mean in speed in designing, speed in manufacturing, speed in research, all those aspects being covering under it. Flexibility. Today, industries are not just industries. Let's take even a simple example as we consumers, right? We consumers look a lot of flexibility in the product. Take whether it is a cell phone. Earlier, cell phone were used to use only for calling somebody and talking. Today, cell phones are with vast features. I see people don't even use computers nowadays. They have all these apps available on the phone, and they can just use a phone as a computer, and they can do a lot of work, right? Similarly, in industry, in manufacturing sectors, people are looking for a lot of flexibility in manufacturing. How the same manufacturing facility can be used to manufacture different types of equipments. If there is a new product that is getting released, how this current facility can you can be used to manufacture it. So they are looking at some optimized facility, right? And quality is never a topic for negotiation, right? Today, any company can survive in the market only if their quality is best, or if they have some quality in the product. If not, the product or the company cannot be in existence, right? We are seeing it in many places. We see the value in quality, and we ourselves go buy only quality products. So quality is never a topic to be negotiated, and everybody are looking on that. Efficiency. Efficiency is let's take an example like in this time of Corona. I'm sure Corona has taught us a lot of efficiency in ourselves, like how efficiently we can use the tools available with us, how to efficiently use the time available with us, space available with us, right? So today, industry is not just industries. Even ISO body like certifying body like ISO is coming out with much important policies, make change and things like that. They are introducing something called green certificate, where all industries should ought to be green certified, which means that the energy consumed by the industries are optimized. So they have to get green certified is one of the policies. In future, we might expect even optimized space usage, because government might come up with some policies where they give equal importance to agriculture and industries. So industries are forced to make use of the space that is available more optimized. Resource optimization, so efficiency is other thing that industries are looking at, how less I spend, whether it is time or money or space or whatever it is, how less I spend and how more I get, is what all industries are looking at. Not just industries, we consumer ourselves, right? So that's where these four major factors is are actually the concerns of an industry, and they are looking at for some solution around this. Okay, and it depends on industry to industry what solution we can provide. As I was explaining that smart factory automation, it is a huge, vast area of in industry. So we in a process industry, the smart factory might work in a different way. The components might be different. The technology used might be different. Similarly, in the automobile or manufacturing sector, it would be different. Right now, we are going to take an example of a manufacturing sector. Okay, how a smart factory in a manufacturing sector will work. This is just an example. So here, this is a smart factory. On top of the smart factory, the digitalization sits in. That is a digital twin sits in, and that makes the smart industry or the industry 4.0. Okay, so what is a smart factory automation? So this is a completely automated factory, which involves, right now in this example, it involves CNC technology, robotics, warehousing, image processing, quality, RFID, and all these different types of technology. So I'll start with a video of a basic understanding on this smart factory. So as I was explaining that this is an automated factory, which is a particular engineer sits on a computer in a software and he programs it completely, and that is done automatically. When I say programming, is he defines like what is the infrastructure of the factory, which means what are the components and equipments available, and what are the individual process, and what is the sequence of the operations. All those has been defined. Once when he defines, then the complete operation is done automatically in a sequential manner. So here the infrastructure available are there is, like, let's take a typical manufacturing sector itself. In a manufacturing sector, what are the basic infrastructure that will be available is there will be a storage space where the raw material or the finished goods stores. It's the stores, and then there will be a manufacturing space where manufacturing of components will happen, like machining, production, or something like that. Then there will be an assembly area where things will get assembled. The product that comes out of the production line gets assembled, and then there will be a quality test area where these products are tested, and then finally it gets stored. Right? This is a normal processes involved in or infrastructure involved in a manufacturing industry. So here we have the similar model here. So we have automatic storage and retrieval system, where it has got the raw materials or the finished goods stored. So it is an automatic warehousing. So we can program it and store the raw materials accordingly. And there is an automated guided vehicle which transports the material to individual stations. So transportation is automated here. Logistics is automated here. And in the production line, we have CNC machines. We have a lathe and we have a VMC, which is used to manufacture the components. So here we are trying to simulate an example of a bearing and a shaft assembly. So there is a shaft which gets machined in the VMC, and then there is a lock which gets machined in the lathe machine, and the bearing gets assembled on the shaft and it's get locked. This is a process of this video what you're seeing, right? So first the job is getting machined in the VMC, now the lock in the lathe machine. As we were explaining that this is a completely automated setup. This is a production line, and the production line is automated for loading unloading using a gantry robot. So the job is automatically picked up from the conveyor, belt conveyor, and then it is loaded into the CNC machine, and the machining will start automatically. Once when the machining is done, it will pick up the job from the chuck and it will place it back into the conveyor. So now the production is done. Then it goes to the next station, which is the assembly station. So again, the automated way using the automatic guided vehicle. So whatever the components that is machined right now, right, the shaft and the lock, it gets assembled with the bearing and to complete the product. So this is a mechatronic based assembly station with robots. So make it more modular. The first is the assembly of the bearing. You could see that in the video. Bearing got assembled. Now the lock will get assembled. In a typical manufacturing industries, as I was explaining earlier, the kind of work the supervisor or the manager will do is that defining the infrastructure, defining the process of the individual stations, and then define the sequence of flow of information to to automate the process, or even if it is manual, how it has to go through it individually, each and every station, and how the assembly is completely done. So right now you could see that the product is completely assembled and then it goes to the next station. So the process that they write will be right from picking up the raw material till the quality testing is done and then placing it back into the storage, right? So that is the complete work that a manager or someone do. Similarly, they're going to do that in the software in the automated way. This is a vision inspection station with the image. This comes with the image processing technology using a vision camera. So we will examine the job which is assembled, and using the parameters that we have stored, it will give a result whether it is accepted or rejected, and then accordingly the job is stored. We can program it like if it is rejected, then it might need to go for a remissioning or rework, or rejected, it has to go to the rejected bin. However we want, we can program. So this is a typical example of a manufacturing industries. It will vary. If it is a process industry, then the process would be different. Maybe there will not be any CNC machine. There would be some other processing work that will be done according to the job or the product, right? So this is the complete automated factory. On top of this is where the digitalization sits in. We're going to see the digitalization later part. So in the smart factory, I would like to cover some of the information which I faced earlier. See, I'm conducting this webinar for quite some time with many of the institute. I get these questions from many students and even faculty sometimes that is this automation going to completely eradicate human, or is it going to take away their jobs, or what is this automation's role actually in industry? See, let's consider an automation. How an automation actually introduced. Okay, let's say from that phase. See, these are some of the factors that you see on the screen where automation is actually forced to be part of it. Harsh or hazardous environment. We're talking about like a nuclear cell, a nuclear industry where a lot of nuclear kind of jobs is done, where restricted usage of humans, or there is a way of working for humans in those environment. Let's take chemical industry, or we can take some of these glass industries or rubber industries where the process has to be very very strict and tidy, that so that they don't face any accidents because of which there might be a lot of injuries that is happening, which happen. You would have heard some recent news in Visakhapatnam as well, right? So those things can be avoided. Repetitive jobs, right? Say, for example, there is a lot of this matchbox making industries in down south in Tamil Nadu. So they make the matchboxes. So where I've been there, I've seen some of these industry how they work. Very very small industries within in 1,000 square feet or 2,000 square feet, they run some industries and all. So there is a lot of people who repeatedly just pick up the matchsticks and place it in the box. This is their job. Just imagine 8 hours a day, 20 days in a month, they just do the same thing. Or even 365 days in a year, they just do the same thing, right? Even they nowadays they don't get proper people to do this job because this is very dull and repetitive, and this is unskilled work, right? So there, an automation is actually being introduced a lot. um, Places like heavy lifting. Today we could see a lot of cranes and automated way of unloading, loading things and keeping things in particular position is coming out, right? Better accuracy, like it could be manufacturing of some microchips and or the motherboards of computers or mobile phones today, right? These are all like very accurate and very very tiny and requires a lot of accuracy. So their automation is being introduced. Complicated applications, like it could be submerged welding. today that's something very emerging in the shipping and submarine industries and all, right? So there a lot of things is happening in this kind of applications. So we are talking about automation that is actually being utilized to save humans or to support humans in a big way, right? And moreover it is actually upskilling a human from an unskilled to a skilled level, okay? Thereby their skill and their salaries and things like that gets improved. I would like to show you an example of this using my product. This is our online e-learning product skill on 365, where we have whatever industry cases or industry skills that we have gained as a knowledge has been made as a content online and given for learning. So let's see. We have one course on robotics basics where it'll tell you what are the different applications of robotics today that industry is looking at. These are broad areas today, and it is according to uh, our intelligence and our ideas that we can explore much more opportunities available.
Robots have revolutionized the industrial workforce ever since its arrival in the industrial field. According to ABB Robotics Analysis of Statistics from the International Federation of Robotics, most robots do very specific tasks and fall into 10 categories. They are arc welding or robot welding that joins metal surfaces. This improves the safety of workers by avoiding arc burn and inhaling hazardous fumes. Spot welding, where two contacting metal surfaces are joined by directing a large current through a spot of an automotive piece. Materials handling, where robots are utilized to move, pack, and select products. Robotic automation, where it is used to loading and unloading of raw materials into the machinery for processing. Robots are used to paint automotive body parts. Robotic picking and packaging, which increases speed, accuracy,
Hello,
and
Mr.
reduces
Arvind.
production costs.
Please be
Robots
louder.
are used to
This
assemble products
order is not clear.
in
Yes, madam.
laser-dry assembly. This increases the
Okay.
reduces operational cost. Robots are also used in the finishing process after processing machinery, such as mechanical cutting, grinding, rebarring, and polishing. Robots are also used in glue, adhesive sealing, and spraying materials, such as windscreen, door sealing assembly, etc. Other processes where robots are used include inspection, water jet cutting, and soldering. Click or press each tab.
These are some of the broad areas of robotics applications that it has evolved. But as I mentioned, under these there are a lot of other applications categories that might come out. It depends on all our innovativeness. For example, I heard that a few days back, I saw some video in some European countries. Robotics is used for in agriculture for plucking fruits. So what they did is that using a vision inspection camera, they fit a vision inspection camera in the robot as an end effector and one gripper, and the vision inspection go checks whether the fruit is ripened or not, and then the gripper go flex the fruit. See the kind of work that it is being done today is massive. Similarly, if you take in the welding sector, we recently worked out for a solution, for the arc welding. Okay, so one of the customer wants he does a lot of welding work for building up the body parts for the truck or the bus. Like the body. If you buy a truck from Tata or Sheikh Leyland, you get only the chassis, right? And then the body or the cabinet is built separately by some companies. They do this work, and they are not getting manual welders, and they want to have automatic robotic welding. And we went and did a complete case study, and then we gave them a solution called laser seam tracking welding. What is the laser seam tracking welding? Is that there is a laser gun that is fit in front of the welding gun. So I'll just explain you using our welding course. There is a arc welding, robotic arc welding courses. This is a cell. This is a welding gun. What you could see here, okay? Uh, uh, Laser gun is fit next to it, where it goes and reads the surface, takes the input of the surface of where the welding has to be done, and gives it as a feedback to the robot and the welding controller, and then the welding is done accordingly, and it gives a very smooth finish. Thereby, the aesthetic is also fine, and as well as the finish quality is also fine. So this is a kind of additional of different technologies are coming into place, because today robotics is playing a very major role in the smart factory automation, right? Because if you, as I was explaining, whether it is agriculture, food industry, I also saw in a news that one of the coffee shop in Taiwan or South Korea, I don't remember, is completely automated with a robot. So whoever wants to take a coffee, they just step into the hotel, and there is a touch screen window in the table. They order whatever they want and do the payment. There is a robot which automatically prepares a coffee, and there is an AGV, automated guided vehicle, which transport the coffee to that particular table and serves the coffee. There is no human at all except the customer who actually drinks the coffee. There is no human at all over there. So this is the kind of automation where robotics is actually playing a very major role in it. Today, it is very mandatory to learn the technology via the application, is because we have to understand how the robot can be applied. Maybe we can start with one or two applications that will allow us to actually learn and understand how this can be applied in many different ways. Because it is not just a robot programming that we have to learn. Say, for example, this is a robotic cell. This is an arc welding cell. Okay, you could see the video first, what it is doing. When I press start, the robot moves to the job. It does the welding automatically. The welding is started. The welding is also continuous, and the robot is also moving continuously on the job. So there is a simultaneous function that is happening over here. And once when it is done, it retracts to its home position. Here, the robot is a separate device and the weld gun is a separate device. They are just interfaced. Because when you order a robo, it doesn't come along with the gun. Always the end effector. This is the end effector, what we see here, the gun, right? Like this, we can put in different types of end effector. It could be drilling, painting, a spray gun for painting. Like that, we can put whichever is required for our application, right? So here it has to sync with the robot. The third party equipment, whatever we fit in, has to sync with that equipment. And there is a lot of fixtures available here where the jobs are clamped, where the welding has to be done, right? So why we are mentioning, why we are urging that you have to learn the technology via the application is that you could see the way the course is built. That will give you the idea why. First is to understand what is this workstation, what is this work environment. The robo has to understand what are the things that are surrounding it. Like there is a gun, there is a fixture, there is a cell, there are sensors, right? And it is an automated one. So I have to talk to each other, and then I have to perform this job in a very sequential way without any accident, right? So first we have to understand what is the entire work cell. Then we have to do an interfacing. The second is about configuring the controller. As I mentioned, that the third party equipment which you fit, right, that has to communicate with the robo, and they both have to work in a synergy, in a sync, right? The only then the job outcome is out. If not, then the outcome is not there. Then I might be doing it again manually. I might have multiple buttons. Press one button for the robot to move to one position. Press another button to start the welding. So the idea of automation is totally diluted there, right? And that doesn't work there. So second one is configuring the control systems. Third one is about creating the tool center point. When let's see what is that. Okay, just want to get into that chapter alone, little bit into deeper, so that you understand what we are talking about, that because only then the programming comes in. After this only the programming comes in. Programming is only a part of the application. First we have to understand, because when we write the program, we will be calling the welding gun to come and do the welding. We might be calling some sensors to come and do some functioning, right? So for that, we have to first understand the first three areas, then do the programming. So this is about we call like in the CNC part, we call it as offsetting. Before we go manufacture any component in CNC machine, we have to take offsetting. We have to make the machine understand that this is a job, and the job is placed in so and so location, and then you have to go do the machining. If not, what will happen is accidents will happen, because the robot will not understand where the job is and where it is fixed and what it is. And if you simply write the program, then it might go and do some accidents. In our course, there are two ways of learning. First, it will allow you to view that set of instruction and how it is, how we have to do, and then you can try the same. So
Let's
for
now
this,
learn how to import a TCP pointer.
so here this course will teach you how to set the TCP pointer for this robo. By default, the TCP pointer of a robo will be in
Rotate
the center of the robot. Okay, and then we have to position it on the fixture table. So for that, we have to enter the coordinates and then place it on the
set
fixture
the
table.
TCP.
Then we have to match the tool end tip with the TCP tip, and then we have to enter the values as a tool center point for the robot. Then the robot will understand where the jobs it and where we have to mission it. Then we have to move the robot, jog the robot, and place it on the
Right
tip
click,
of the gun.
enter, type the value. Double click in the Z coordinate field. Type the value 560 mm and press enter on your keyboard. Note that the position values are entered, which is relative to world coordinate system of robot workstation. Close the page. Zoom in to view the robot PCB closely. Now, the tip of the arc welding torch is placed above the tip of the TCP pointer. This is the first approach point to define the TCP.
Right, then if you want to do the welding in this fixture, then we have to set it for over here separately. Then the welding has to be started. Then you will write the program, and when you write the program in the robotic controller, then it will understand where the job has to be done and what the welding has to be done. So the idea behind teaching uh, the robotic or any automation in the application way, I hope you would have got this point right now. So once when I'm done with this course, then I will be able to know how we can do this for different other applications. It could be like painting or drilling or boring, whatever we just saw. We can do that. Similarly, you will, for example, I myself in my company, and there are few other people in my company who give a lot of automation consultancy to various industries today. They give automation solutions to them. So that's how we learn the application, because we need to know various ideas, various other technologies, then how to interface, how the robot can be interfaced with that, and then give as a overall a solution to the customer. So now, till now, what we saw is on the smart factory part. So we saw all the automated factory, robotic, how it influences, and all those things. Now, on top of it, as I mentioned earlier, the digital twin or the digitalization sits, right? So we're going to see what is this digital twin or what is this digitalization that we are talking about. So digital twin is actually a virtual representation of it could be a physical product or it could be a process. So I'm representing or getting that into a virtual environment to understand its behavior. I'll predict its behavior, its functionality, its characters, and all those things. And if I have to change few things to get an optimized outcome, I can do all those things in the virtual environment. That is called digital twin. Let's take an example, like a case study, to have to get more clarity on this. I work for this under my digital factory product line. We got a call from one of the industry in Noida who actually manufacture a lot of this automatic warehousing system for e-commerce website like Flipkart, Amazon, Tata Click, and all. So they set up the warehousing automated warehousing system. You would have seen this kind of videos in Discovery, and even in YouTube you can see how an Amazon warehousing factory is automated. So they manufacture similar such setup. So they got an order from one of these companies, and their delivery time is actually 12 to 15 months. See, these are not standard products that they can manufacture and keep it ready and then deliver it immediately as and when they get the order. No, because these are like unique. The customer will define what is the size of the warehouse, what is the size of the pallet, what is the size of the individual pallet holder where they have to keep the job, right? Accordingly, the warehouse has to be built. In this case, a warehouse is roughly about 750 meter by 500 meter, if I'm not wrong. This is the kind of warehouse that they are building. It's huge, right? There are multiple rows and columns of ASRS racks and pallet conveyor that moves to pick up the job. So they called us to give them some solution where they can reduce the time and give a customer a better solution. So we went and did a complete case study, and and we understood that their design work is more or less faster. They completed within 3 to 4 weeks because they would have got some predefined one, and they just need to come alter the sizes and get that ready. After that, what they do, they take that CAD diagram and they go manufacture it. Well, when they manufacture it, and then they try to fit assemble it, and there is a lot of fit issues, assembly issues. It's not assembling properly, the dimensions are different, or they have to correct the file. Again, they go do the correction in the design. Again, they go do manufacturing. Again, they come and try to assemble it and fit it and see if it is working. Sometimes it is going for 3 to 4 iterations of this, and after they make sure that the fit is all pakka, then they go connect the motors, sensors, conveyors, and they connect it to a controller, and they try to see how it is functioning. There again, if they face some issues, again the design change, again manufacturing, again fit assembly, again go try to process. So again, there 3 4 iteration. Remember, when a manufacturing has to be done in this way, then it will definitely take a very long time, and moreover the cost is increasing every time. It is not just a soft a design that they're doing in a software, right? Because here it is they are manufacturing it. So the cost is incurred is very high. So they want to reduce the cost as well here, along with the time. So what we gave them the solution is a digital twin. Okay, what is a digital twin is, when we do the design. So digital twin has got two parts. One is a design part. Once when you do all the CAD layout and all the CAD designs and all, we apply the kinematics to it. Whatever physical properties that you mentioned, like you would mention, like this is a dimension, this is a weight, this is a type of the material, all those things, and then we apply the kinematics. Kinematics is if it is a movement, if it is in moving, it is a rotary movement or linear movement, how is it functioning. So those kinematics is also applied, and it is completely tested in the virtual environment before even getting into manufacturing. I test all this its behavior in the software itself, apply all those conditions, environment conditional and type conditional, process conditional, everything, and I see how it's behaving. So, in our term, we call it as virtual commissioning. Once when I complete the CAD layout, I import it into an environment where I assemble it virtually. And if there is a fit issue, or if there is an assemble issue where the dimension has to be changed, I can simply change it in the software, right? It's only a soft virtual one. I can immediately go change in the design and again see if it is fitting properly, and whether I can screw it properly, all those things. Then I can connect it to the controller. Anyway, I'm applying the kinematics there. Then now I can connect to a controller. It could be a PLC or a HMI or a SCADA or a CNC, or a VFD, whatever it is. And then I give an input from there, and I see how it is reacting, behaving. And if there is any problem, then we can rectify the issues there, and then we are making the product more optimized before even getting into production or implementation of it. So let's take a simple example. This is our we do a lot of testing in our product as well. This is testing our ASRS, okay, or automatic storage and retrieval system. So this is one kind of testing that we do. This is the ASRS pallet testing. So this is an ASRS where this is a pallet conveyor, okay, and these are the number of pallets. We have 18 pallets in there. We are just trying to test whether it is moving to the right pallet when I program it, because this is connected to the PLC. The input is from a PLC. This is controlled by a PLC. Sometimes, there are the errors could happen or accident could happen even when a program is wrong. So we can also validate our PLC program whether we have the right program or not, right? So what we did, we input all the parameters here, the position of every pallet, tag that with the PLC, and give the input from the PLC and see if it is moving to the correct position or not. So say I'm switching on the position number one. Is it moving to the position number one? And when I say go retract, whether it is retracting to the home position or not, right? So these are some of the testings that I do and ensure that the product is fine. And then I go for manufacturing or implementation. Now, this digital twin has got three major modules in it. Okay, first one is a product digital twin or product digitalization. Second one is production digitalization or a production digital twin, and then the performance digitalization. These are the three major modules of uh, the digital twins. They are all interconnected. Okay, it is the sequential way. First the product, then the production, then the performance. Okay, and there is a continuous feedback in the reverse way, right? So we will from the performance there will be a feedback to the production, and from production to, I mean, from the performance we can also give the feedback to digital twin as well. Thereby, even after, because the digital twin, when I mentioned digital twin or digitalization, we are saying that it is a predicted value, right? So with the predicted value, after we implement it, we will have the performance analysis of it, which is a live active actual values that will be given as an input back to the digital twin and ensure that it is getting optimized much better. Okay, so first let's see what is a product digital twin. So let's take an example of that Hyundai Creta car, which I mentioned earlier, right? So, and we were talking about speed to market. Speed to market, first point is speed in design and speed in mainly getting the product design and optimized faster. That is a product digital twin. So, whatever the product that we design, we do all the testing in the software or the virtual environment. We get the product optimized. Whatever physical testing that we can do it in the virtual environment, and we ensure that the physical product performs, as per our desired results. And then we are now confident enough to get the product out in the market, and maybe after production we can do minimum testing, and then we can release it to the market, and thereby the product is actually much optimized. This is on the example. I would like to show an example on the product digital twin. The product digital twin, let's take an example of MTAB. We ourselves manufacture a lot of CNC machines, right? We did one of the five-axis machine to one of the customer recently, and we did a complete digital twin concept in that to make a fast delivery. So there is one called access testing in our process. So we do the access movement testing to ensure that the when we move it, it doesn't go hit the cabinet, and it doesn't cause any accident. At the same time, it is moving as per my design. For example, when I design the machine, I mentioned that x-axis is in so and so travel, y-axis in so and so travel, z-axis in so and so travel, right? And then this is especially a five-axis rotary table is fit on top of the VMC table, and so when I move it, I check all these things that the travel is also to that limit, and when I do that and there is no accident happening, because when if I do this in the physical environment, what will happen is, and if there is an accident that it goes and hits the cabinet, then I have to scrap the cabinet and again make a new cabinet and come fit it in there. The cost is high, and at the same time I have to wait until the new cabinet comes in and again do the testing again and see its performance, and thereby the time taken is also huge. I'm rather trying to do all those things in the software itself, and I can also connect it to an actual controller and see if the machine is behaving properly or not. So like this, different types of testing can be done for individual features or individual parts, and make sure that the product is optimized. So once when I manufacture it, and then I'm now my product is designed and about to delivered much faster than comparatively earlier without the digital twin concept, right? Now it is not just the product, right? As I mentioned, the speed to market involves speed in research, speed in design, speed in research and everything. Also, speed in manufacturing. Once when I done my Once when I designed my product, and now I'm very confident that the performance of the product is fine. Now I have to optimize my production line, and once when the product goes through the production line, if the production is also optimized and faster, then the complete cycle is faster, and the product reaches a market much faster. So that's where production digital twin comes into play. Production digital twin is where we do a complete digitalization of the production line, and we optimize it. We give all the conditions, if and else conditions, and see how it is behaving, and how we can optimize it. Because more other thing is that many people are not ready to actually test it out in the actual physical factory. Let's take an example like the Hyundai factory in Chennai. Okay, If I am the engineer who has to optimize, if I have to go there and say, give me the factory for 1 month, I will do a complete study and I'll optimize and I'll give you result. Imagine if the factory is producing 30 cars a day, and 30 into 30 days, 900 cars in a month, roughly 5 lakhs is the cost of the car. Imagine the loss that the company is taking, right? So they are not ready to do anything in the physical factory. They want to do it in the virtual software and optimize it, then go implement it. We call this as, in our term, as a brownfield project or a greenfield project. Brownfield project is where we optimize the existing factory. So we get the complete infrastructure in the software. So what are the basic missions available, machineries available, infrastructure available, and what is the logistics, the movement of it, what is the sequence of operations, right? What is a cycle time taken by the individual machines? All those information are fed into the software and then tested out. So let's see with an example, right? This is a smart factory with the video which we saw in the beginning, right? It's the same thing. So I defined the infrastructure here, like what are the missions available, and then I apply the cycle time of the individual missions, and what are the processes involved in that individual mission, and what is the sequence flow of the complete setup, which station it has to stop, and what operation it has to perform there. And then it can also analyze like what are the energy that is consumed by individual missions, what is the time taken by the individual missions here, if I increase the speed or decrease the speed, how is the performance getting hit, what is the output of it. So all those studies I'm trying to do, all the if and else but conditions that I want to do, I'll put it in the software, I test it out, and then I can go for implementation. If it is a new project, then we call it as a greenfield project. So even before I go for implementation, I do the complete virtual design of it, even the entire factory, give all the constraint in terms of energy, in terms of space, in terms of resources, right? And then and process, and then see its output. And if I have to optimize, I can optimize. Say if it is an industry where I say I have to manufacture 30 cars in a day, so we do that top-down approach. So then I define what is infrastructure required, what is the process it should be involved, how fast it has to run, and if they have to increase infrastructure, all those modifications that can be done later on, right? Once this, when I do this analysis and I complete all those things, then it will give me the complete data, like what is the outcome of it, what kind of energy it has consumed, what kind of time it has consumed, and what are the machineries that is available. All those data will be with me, and then if it is a brownfield project, if it is an existing factory, I can go phase wise optimizing things. Or if it is a greenfield project, I have the data with me right now. I can just straight away go and implement it. So that is the idea behind optimizing the factory, and this is on the production digital twin. You could see that how the data are coming out on the optimization of the factory, right? So then using which we can go ahead and implement the optimization. Fine. Now, till now, what we saw in the digitalization is product digitalization and perform production digitalization, right? Product and production digital twin. Those are predicted values, right? As I mentioned, we are trying to predict how behavior of the product and the production line. Um, so here, the third phase is the performance digital twin, okay, where the major part of the IoT or Industry 4.0 comes. That is the IoT part, right? So that is the one of the major sectors of the Industry 4.0. What is this IoT? Okay, we're not going to look deep into individually about what is this IoT technology. We're going to cover how this IoT actually plays a vital role in Industry 4.0, because Industry 4 IoT is not a concept of something only related to computer science students. No, see, as I mentioned, where is this applied, right? We have to see where the IoT is actually applied nowadays, right? It's in the manufacturing area, or it is applied in an industry, right? Majorly in an industries where the right now the consumption is high. So it's basically it's important for even the all different departments, individuals to understand the basic knowledge on this IoT, so that when they go to any IoT based industry or any industry which has adopted this IoT technology or Industry 4.0 technology, you will be aware about its functioning and working, and you will have the skills and knowledge on top of it, which right now industry is looking at. Okay, so now getting into this IoT, let's take an example case study. Okay, I am the owner of a factory. Okay, and I want to know what is happening in my factory, right? So say it's around 2 p.m. I call up my manager or a supervisor and I ask him like, what is the performance of the factory in the morning shift. By the time you would have written, you might have collected the data in a paper or a diary or in a Excel sheet, and then he might have all this data with him, and then he will have that manipulated and prepare some graphs, some charts, and then he will send it to his owner or boss or whoever is asking for that information. By the time it will be 5 or 6 p.m., end of the day. An owner today, the way that we are talking about speed and flexibility, right? People are looking at getting information at a very much faster speed. That's when IoT is introduced. Not just faster, information accuracy is also something that everybody is looking at. Survey says that there is a lot of errors that is occurring when manual data entry is actually happening. So when IoT introduced, the way it works is that it talks directly to the machine. Vision gives all the information that it can possible out for us to collect and analyze and then do the performance analysis of the, it could be individual product or it could be the entire factory, doesn't matter. So thereby we can optimize both. That is the performance digital twin. It has got four main processes. These are the four main processes of an IoT. Okay, process one, connecting things. Okay, connecting things is, as I mentioned, the idea of implementing IoT to make it faster is talking directly to the machines, right? It should be a smart machine. It should be an IoT compatible. So there are a lot of machines coming out with IoT compatibility, so that will not be an issue. Or we can add up some sensor to make it to collect what are the information that is required out from the machines. Okay, so there will be a central controller which connects to different equipments or different machineries in the factory or to the particular product and collects all the information, and then it pushes to the cloud, to the internet. That is the first process. Okay. Second process is data analytics. Whatever the information that has been received, it has to be analyzed and structured. Okay, there should be a structuring of the data. So, for example, in a factory, there could be a maintenance engineer, or there could be a owner, right? There could be a supervisor who might require different sets of information. It is not mandatory that we have to give all information to everybody. For example, a maintenance engineer might need to know some information like what is the oil level in a in the machine, right? Owner might not know that. My owner might be requiring an information like what is the total output of the machine or the factory today, right? So everybody is looking at the different sets of information today, right? So data analytics is nothing but structuring that data. So machine gives all this information. Machine gives information like what is the oil level in that machine, what is the total manufacturing output of that machine. All those information is being given out by the machine. We have to structure, we have to write an algorithm and structureize the data. Okay, then we have to push it out. So it gives, we have to mention like which data has to be displayed for owner and which data has to be displayed for the maintenance engineer. Okay, that is the second process number two. Process number three, application development. Today, presentation is a very major role today. It's playing out every place, wherever, all the places, right? Because say for example, I'm the owner, and if my manager gives me an Excel sheet or a list of data, say 1,000 lines of data, and he gives me the data and says like, sir, these are the all the information available, and you can just read through it and I can understand. By the time I read the entire data, it might take 1 day, 2 day, or 1 week. We're not sure, right? So something very presentable, giving with some charts, with some graphs, so that he can easily analyze it and he can understand it in few minutes. That is something that everybody is looking at. So the application development is nothing but presenting whatever the data which has been structured. We are trying to present it in a visual way so that it is easily understandable. That is a process number three. Process number four is deployment. We are making it live. Okay, whatever we process we have done right from one to three, we are making it live. We are deploying it and making it available for it to work. That is now process number four. So today, what we studied is the complete automated factory. On top of it, where the project digital twin sits in to analyze the individual product, and then the complete production digital twin sits in, where the we analyze the complete production line, and then the performance analysis sits in, where we analyze the performance. So then we have the actual data, and we give feedback back to product digital twin or production digital twin to optimize more. So this is the summary. By that, I have completed my session today. So to just to give you a brief about our e-learning product. So as I mentioned, I handle these two main businesses, digital learning and digital factory. So digital factory is where we provide a lot of IoT solutions to various customers, and those knowledge is now converted as digital learning, and then we provide that as a online product, e-learning product to various customers today. Our online product is very interactive, and it is built to industry standards. I just demonstrated you, right? So it is more interactive, easy to learn, and understandable, and it is to industry need and what industry require today. That is how it is being built. Okay. So with that, I'm done with the presentation.